Hello everyone and welcome to another video. Today I wanted to talk about one of the most popular databases used in AI and ML research and development, the MNIST Database. The main goal of this video is to show how to download the raw database, parse it into organized data structures, and then import this into MATLAB. We're going to save topics such as training models based on this data for future videos. So you might ask, what is this? So MNIST stands for the Modified National Institute of Standards and Technology, and I have to say this name isn't very descriptive because what this database consists of is actually a large number of handwritten digits between 0 and a 9. Now, in addition to the digital representation of these handwritten digits, the more important part of this is that there are associated truth labels for each of these images. So this makes it ideal for training AI and ML models that can leverage labeled data sets. So in other words, you basically are given a 28 by 28 set of basic numbers which represents the grayscale value of a given image. So for example, this picture down here, you can see that you get a 28 by 28 array of information which approximates, and I mean, this looks like a handwritten number 1. And like we said, what's important is that the data set provides a label and says, yes, indeed, the image number, 47,042, that is actually a number 1, right? So there are 60,000 training examples and another 10,000 testing examples. So if you really want to think about combining them all together, we're really talking around 70,000 examples of data and then 70,000 labels as well. So that's what the database is made up of. It's 70,000 28 by 28 images effectively, and all of their associated labels. Alright, so now that we know what the database is, how do we get our hands on it? So the name that's most usually associated with this data set is probably one of the largest, most famous, well-known names in AI and ML, and that's Yann LeCun. So he put this database together, and in fact, if you just go ahead and go to this web page, or if you just go into Google and type in MNIST Database, you'll get a lot of hits, right? And it's actually this one right down here. This is Yann LeCun's web page where he has the original data set. Now, what's interesting about this is if you try to access this website using Google Chrome, you might get this where it wants you to sign in. I don't know how to sign in. You might get this unauthorized message. So long story short, don't try to access this with Chrome. I had problems. I have good success though if I use Microsoft Edge. So if you go to that website using Microsoft Edge, you get in fine, and here is the information about the data set. And as you can see, there are 4 files here available for download in compressed format. So again, what these are is this first one is effectively the 60,000 images for the training set. The second file here is the 60,000 associated labels for each of those images. And then you have a similarly smaller set of 10,000 that can be used for training, and again 10,000 labels. So overall, these 4 files, you should be able to get all 70,000 examples and labels. Now, the problem is when you download these, you're going to notice that they're not organized in individual images. These are effectively, you're going to get one file with a bunch of raw data that we are going to have to parse. So that's what all of this discussion here is. It's talking a little bit about the data set, as well as, if we keep scrolling down, he's got information on performance of different models against this, but we really don't care about that right now. All we care about for this video is obtaining the data set. So that's what this section of the discussion of the website is for, and I would recommend reading through this entire section because it tells you very valuable information about how to parse the raw data that you're going to download. So for example, it says that all these integers are stored as big endian or most significant bit first, so you're going to have to worry about that when we're reading it in. Also, then what it's going to tell you is about each of these 4 data sets. Those 4 files, the data is structured in a very specific format. So we're going to talk through this, but maybe what might be helpful is let's just talk about this. Let's talk about the training data here, right? So this is the 60,000 actual images. This file here is the 60,000 of the labels, but I think it might be more interesting to just talk about the images because that's probably the most complicated structure. So you're going to see here that first in the data set, in this big giant array of bytes, the first 4 bytes is basically representing a 32-bit integer, which is this magic number of 2051 in decimal, right? Then the next 4 bytes is actually another 32-bit integer, which represents how many images are in this database, and it should be 60,000. Then again, you have another 4-byte integer, which tells you the number of rows per image, and then another 4-byte integer, which is the number of columns, and then you just start getting into the data, right? And then it says pixels are organized row-wise, etc., right? So again, read through all of this because this is going to tell us how to download and parse the data. So I've got actually a couple of slides that might make this a little bit more understandable. Let me jump over this and we can go and talk about what does this mean and how can we use this to write some code to parse the data. Alright, so here's a little table I've made. So like we just discussed, when you download the data file and decompress it, you're just going to get a file which has a lot of bytes in linear sequential order. Now we just need to understand how to interpret each one of those bytes so we can parse this into a more coherent data structure. So pursuant to the website discussion, the first 4 bytes we saw was a 32-bit integer which should have this magic value of 2051, right? So we're going to read 4 bytes, we're going to make sure that it's equal to this. Then we're going to read the next 4 bytes, and we're going to read it should also be equal to 60,000, right? This is basically telling us how many images are in this data set. Then we're going to read another 4 bytes. That should tell us the number of rows per image, and again, this should read 28. Same thing, we're going to read another 4 bytes. That should be the number of columns, which is 28. And then finally, when we get to byte, what is this? Byte 17 in index 16's position, right? Now we're going to start reading individual data for each image. So for example, let's take a look at the first image that's contained out of these 60,000 individual handwritten images, right? So we know that it is a 28 row by 28 column matrix, and this element right here, byte number, what is this, 17, right, in the database, this actually is the first row, first column. So whatever value we read here corresponds to kind of the grayscale value of the image in this position, right? And then all we're going to do is we're just going to keep moving down. So the next byte in, here, in index number 17, so I guess this is the 18th bit, right? That is going to be the next element in the row. Remember, all the data was arranged row-wise. So you keep doing this, moving along. So these 28 bytes here are basically the first row of the first image, right? And then you're going to keep going down and you're going to repeat this. So the next 28 bytes after that are going to be the second row. And then the next 28 bytes are going to be the third row, etc., all the way until you build up one entire image. And then you're going to start this whole process over, and we're going to start, and it's going to read another image, right? So you can just repeat this process over and over. So you can see that it's basically repeating this pattern, except for these first set of bytes in the data set, which represents some of this header information. So with this information in mind, we can basically go ahead and write ourselves some code to download the databases, unzip them, and then parse them according to this scheme to basically build all 60,000 of these images for this one data set, or this one file here. We could then use the same code to do the testing images, right, which was a 10,000 size set. And then we could use a very similar format to also parse the labels, but keep in mind now that the labels, they don't have a 28 by 28 scheme. If you read the webpage, you'll see that the label files, all they do is they basically have a integer which tells you what that value is supposed to be, or what that image is. It's either a 0, 1, 2, 3, 4, 5, 6, 7, 8, or a 9, right? That's all it tells us, right? So I think enough of me talking about it. Let's jump over to MATLAB. I'll show you the code that I use to basically download and parse the data according to this scheme. Alright, so the code I'm going to show you is available if you'd like to download it. It's at this URL down here at the bottom. So this is just a GitHub repository that I have all of my YouTube kind of examples and lecture scripts available for usage. Now, that being said, a lot of the scripts, including what I'm about to show you right now, they actually build upon and require some dependencies that I have put into another one of my repositories that I call the MATLAB LUM repository. So that repository is available at this top URL, and I made a completely separate video talking about how to obtain that repository and how to add or quote unquote install it so that you can use all of the functions in the MATLAB LUM repository in a lot of different projects, such as the one I'm about to show you right now. So again, what you need to do is, if you want to follow the code that I'm about to show you, is you're going to need to download and install the MATLAB LUM repository first, following the steps outlined in this video. And if you do that, you'll then be able to go ahead and download the code snippets and the examples that I'm going to show you in this bottom URL, and basically follow along just like what we're doing right now. So that's the game plan. I'm going to assume that you've already gone ahead and done that. So let's go ahead and take a look now at MATLAB. So here I am. So I've gone ahead and fired up MATLAB, and it's gone ahead and I have installed the the MATLAB LUM repository. So I've got access to all the functionality. And again, here's the code that you can download. And this is going to basically download the MNIST dataset from the website. In fact, that's what this first step, step 1A, is going to do. Let's go ahead and take a look at this. And again, like I said, all this does is it basically goes to the Yann LeCun's website, right? And it's going to download those 4 files we talked about and unzip, basically, and decompress them, right? And unzip them. So tell you what, let's put a breakpoint in right here first, and let's just run this, and you'll see that the first thing all this is going to do is just download these. There you go, right? See, they show up over here. So you get 4 compressed zipped files, right? These things are, you know, fair size, you know, about, I don't know, about 11, 12 megs, something like that. And again, it's just the images and the labels for the training data, and then the images and the labels for the testing data. Oh, excuse me, I was pointing to the opposite ones. But you get the idea, right? Training data here, 10K of test data there. Okay, so that's all we're going to do is download on this first step. Now all I'm going to do is I'm going to use MATLAB to unzip these files using gunzip. So let's go ahead, I'll put another breakpoint in like this, let this thing run, and you're going to see that there it goes. It unzipped those 4 files, so we end up with these 4 folders. And if you go into one of these folders, for example, let's look at the images for the training data. And again, what we see is that we don't get a whole bunch, we don't get 60,000 pictures, we get a 46 megabyte file with just a whole bunch of bytes of information that we now need to parse, right? Okay, so let's go ahead now, and that brings us now to step 1B, which is taking these files that we've gone ahead and downloaded and unzipped, and we now need to parse them according to the scheme we just discussed, right? So here's the code. Again, I'm not going to walk through every single line since you can download it and run it yourself. What I will mention is let's just go ahead and first do, it looks like I'm going to look at parsing the training set images, right? So this is the one where it should have the first 4 bytes should be a int32, and it should be this magic number of 2051, so I'm just going to check that. Then the next one, it should be the number of items, so I'm anticipating this to read, hey, 60,000 items to read here. Then we should have the number of rows, which should be equal to 28, the number of columns, which should equal to 28, and then we can start dropping in and reading it byte by byte to get basically the pixel by pixel of each image, right? So tell you what, let's go ahead and I'll put a breakpoint down here. Once we go through the one item, so this will basically allow us to build one full image here in the matrix A. This A should be a 28 by 28 matrix of grayscale values, and let's just run this to see how this looks. The only other thing that maybe I'll mention here is notice here that when I'm opening the file, I'm going to use a machine format of, again, big endian, because that's what the website said the data was stored as, right? Okay, so let me go ahead and run this. That gets us down to here. So again, now what we've got is we've got this variable A, which is, yes, indeed, a 28 by 28 uint8 that looks like, in fact, we can kind of just take, well, you know what we could do? Let's double click on it, the variable, right? And all this thing is, it's a 28 by 28 matrix, right, of grayscale values, right? And you can see, well, it's kind of hard to see what this is by just looking at the numbers, right? You can kind of see that there's numbers here in the middle. But what's better than this is, you know what we should maybe do is let's visualize this using IMShow. So let me see if I can get this window. Sorry, this my mouse is a little bit finicky. It's always a little hard to grab. There we go. Okay, let's go ahead and do a figure IMShow A. Okay. And what that should do is it should help us visualize this 28 by 28. Aha, look at that. There we go. This is what this looks like. So this one, I don't know, that looks like a 5. I'm going to hope that the label associated with this is also a 5. Okay? So you see, that's what we've got. We went ahead and we successfully read all the data for the first image. Then I'm just going to go ahead and make a three-dimensional array. So this is going to be a 28 by 28 by eventually 60,000 three-dimensional array. And each dimension along the third dimension is going to be a different image, right? So I'm just going to do this here for the training data, training images, right? Then I'm going to do a very similar process for the labels, right? And then I'm going to do the same thing for the test set images, and then down here at the bottom, the test set labels. So all I'm doing with this file here and this script is just parsing all of that information, storing them into MATLAB data structures, namely these three-dimensional arrays, and then I'm going to save this to a file. So this might take a little while to run. In fact, let me go and take off the breakpoint at this point, and let me go ahead and finish running this thing and let it rip. And you're going to see this is going to take a little while to complete. So I'm about, 2-3% through the 60,000 images. So let's let this run. And by the time we come back, what I'm doing is this should hopefully write out something to MNIST which will appear over here in my Windows Explorer. And it will have all of the parsed information. It will have all of the 60,000 training images plus the 10,000 test images and all of their associated labels, all stored into a convenient MATLAB.mat file. So let's come back in a couple minutes. Okay, it looks like we're getting pretty close to finishing. So again, when this completes, what we should see is something called, I think it was MNIST Data. Is that what I ended up calling this? Show up. Oh yeah, here, MNIST Data. .mat. There it is. Yep, there we go. Pops up. There we go. So it just read. We parsed all of that information, and now we've got this in a 11.5 megabyte MATLAB.mat file. Okay, so all of the data should be here in relevant data structures that we can now directly manipulate. So let's take a look at this last step, step 1, to see where we can familiarize ourselves with this data set to just see what it looks like. So all I'm doing here is, let me go ahead and just put a breakpoint here. And again, remember that what we've done is we've now stored all that information into this MNIST data.mat file. And again, there's just 4 pieces of information. So the images, right? So here are the training set images. And again, if you hover over this, you'll see that, it's a 28 by 28 by 60,000 element array. So that's 60,000 training images. We've got training labels, right? So it's a 60,000 element vector, which tells us all of the different labels for each of those images. And then similarly, we've got a similar structure of 10,000 test images here, and then 10,000 labeled vectors. So let's just randomly pull out, 9 of them, just to see what they look like. So that's all I'm doing here is picking, do I want to look at training images or test images, and picking out just some random few of these. In this case, I think I'm pulling out 9, and I'm also pulling out their associated labels. So here's what it looks like. So here are 9 random images out of the training set. So here's what they look like. And as you can see, this looks all pretty darn reasonable, right? You get these things that look like a 9 here, and the label is indeed a number 9. And then again here at the 54,347th element, that's apparently an 8. And again, this is what it looks like. So this is working quite well. We've got all of the arrays. We've got all the data parsed into these MATLAB data structures that we can use. So this is pretty exciting. Maybe the last thing that I'll show is, it's kind of fun. I pulled out some indices that are these are some examples that I think are a little bit ambiguous. For example, let me just pull these up, and you can compare them. Let's make these bigger. What in the world are these, right? This is supposed to be a 0, so I don't know who in the world writes a 0 like this, but again, this provides some of the richness in this database, that there are some of the examples like this apparently is a 0. This is a 2. I have no idea how somebody wrote a 2 that looks like this. And again, this is a 9. So again, these are some interesting examples that I think it'll be fun to see what happens when we throw a learning algorithm to try to learn these examples in the context of the other more coherent examples. So that's the game plan for later discussions. Like I said, today all we wanted to do was basically show how to download, parse, and use the MNIST dataset. So right now we've got this where if you go ahead and just download my code and use it, you can generate this file as well, meaning that you'll have the entire MNIST database in MATLAB ready for use in any of your AI or ML algorithms and test cases that you'd like to use. So that's the game plan. In fact, at one of our very following next videos, we are going to use this database to train a neural network to basically do effectively optical character recognition, right? We are going to have the neural network classify each one of these images into a digit 0 through 9, right? And we're going to use the label to help correct behavior. So this is going to be fun. It's a good data set that we can use. And again, all we wanted to do with this video was talk about how to get the data set so that you can use it now for other applications in the future. So with that being said, I hope you enjoyed the video, and if so, I also hope you consider subscribing to the channel. Surprisingly, if you just click on that subscribe button, it really does help me continue making these videos. And the new videos come out every Monday, so I hope I'll be able to catch you at a future discussion and we can all learn something new together. So until then, I think I'm going to sign off. Talk to you later. Bye.